Okay, now we're going to do active physics. The next activity is home.12, 1.3, 1.4. So taking a look at our pacing guide here, there's some interesting information. 1.2, the right size. It says you may need to supplement students' data on home sizes. And I'll talk about the necessity for that. And then what to focus on here for the assessments, physics goal number 1 and number 7. So let's dive in there and talk about that based on the pacing guide. So the whole point activity 1.2 is to have students actually draw a blueprint, a design for them to start building their universal dwelling. So when they begin, they're going to basically go over what they did for homework, the total floor area of a home. If some students did not do that homework, this is where you need to supplement. So either provide data from the size of the schoolroom, or even from your own home. Students like to always get a little window into the lives of their teachers, so you could provide even some data from your home, and those that didn't do the homework could use that data to answer these questions and begin a discussion about how big. Basically, the whole point of these questions here for students as they work on is figure out how big should a universal dwelling be. And once they decide on that, they could actually start with the blueprint. Physics to go number 1 and number 2 is just kind of practice for them of drawing a blueprint and using graph paper and a ruler, a scale of like 1 square for 1 foot, making it simple. They're just going to basically draw what they see here is a little blueprint of their room. This is a round example, but most students, I'm sure, live in a square, rectangular shaped room, so it should be pretty straightforward. So you just want them to practice that individually so that then, after you check and students got that done, you actually skip over these questions to save time and go right to physics to go number 7. You have students get back in group and actually make a design, a floor plan, and a blueprint for their universal dwelling. And as you see students working, just a little advice, trying to keep it simple in regards to the inside. Tell them not worry so much about, the details of the inside. The simpler it is on the inside, the easier it will be for them to build and also collect heat and data. So you could tell them you could leave out the details of the inside, just draw the basic, perimeter and shape of your home. And that's what you want students working on in their groups with a graph paper. And as soon as they're done with that, you can actually give them the materials and start building, because I'm going to explain you're actually going to skip over, or I recommend skipping over this activity, the shape of the home, activity 1.3. What you could do is mention to students, I like to have them, be creative with the shapes as they're doing and they tend to, as they're designing it, you tend to have some creative influence in there from certain students. But this lesson, the shape of the universal dwelling, is not important because they're no longer assessed on this in the BPS assessment, and never on the MCAS have they been asked the question on how does surface area to volume ratio affect heat transfer. So although the active physics curriculum does address that factor of heat transfer, they're not assessed on that. And that's really what this lesson is all about. So I skip it because it's a lot of prep work, setting up these little cardboard grids and getting everything ready for groups. And they're no longer assessed on that. So you could mention to students a square, rectangle, or a dome shape tend to have a better surface area volume ratio, which will aid them in heat transfer. However, I skipped this lesson to save time. And after students have done their blueprint, I go right into the next lesson. I have the materials already there because some students will finish, some groups will finish quicker than others. And those groups that are finished can start working on activity 4, building the universal dwelling. And once they build it, they're going to test the universal dwelling. So there's a picture of a setup here with the materials, the ring stand, the heat lamp, trying to control for the distance, and the tape and the cardboard or cardstock. So if you don't have a ring stand, you could try to set up these heat lamps using taping it to a wall or on some books. Get creative, a desk, but you could try to set this up if you don't have ring stands available. Okay, and recording and collecting data and then analyzing the data. That's what this is all about. So they got their blueprint done, and you can mention kind of like, in the U.S. we're used to really big, large areas of living, but go to IKEA or anywhere else in the world, and we don't necessarily need such huge square footages. So something to discuss with students as they're working on their blueprints and as they're going through lesson 1.2. And then they're going to start building. And again, I'm not doing lesson 1.3, so they could be as creative as they want with the shape of their home. And I actually encourage that and offer, not only am I going to have a reward for the most heat, the home that was best with the heat transfer data, but also the most creative design. So something to get them really working hard on that. Give them a little incentive to spend some time designing and building their home. All right, so they'll probably need some help setting up a data table. Just guide them on that. 2 columns, one for time, one for temperature. Help some groups initially with collecting data, making sure they're keeping careful track of time. And then graph and send a graph, making sure X is for time, Y is for temperature. You may need to guide them through that. And these are just example graphs I pulled online just to show you. Basically, you want to see, it's not going to be this drastic here, but you do want to see, it's most likely going to look like this blue line right here. A little bit of temperature increase, stabilizes, and then during the cooling period, temperature decreases. So depending on the scale they use, you're going to see a little bit of a bend there. And then they're asked to find the change in temperature. You want to introduce this. They're going to be using delta T and a formula for heat. So why not introduce it now since it's asking them to find temperature change? Final first, takeaway initial. You may need for your English language learners, explain initial means starting. Put that on your word wall there, your tier 2 word wall. And, have them use this to find the temperature change and use that to analyze their data. So you're looking at about 3 to 4 class periods here. All right, by the time they build, test, and analyze data, making those graphs. And the material's pretty easy to come by here, except tape, get that for like $1 at Walmart if your school supplies doesn't have enough tape for you. Cardstock folders or cardboard you could get for free. And thermometers and heat lamps are really the only things you need to hit that science supply closet for. I hope they have that there. And heat lamps and bulbs, although you could buy these things, they tend to be a little pricey, but hopefully you have some of that available. All right, so taking a look at this, it's all about collecting that data, analyzing the data, and if you look at the pacing guide, it tells you basically that you're going to need to supplement a little bit here, okay? It talks about a 15-minute lesson on the 3 types of heat transfer. But you're going to want to supplement a lot more because you could see a lot of standards addressed here. So in my next video, I'm going to go over some of the activities I use. So I add a couple days onto this of just supplementing to hit these standards. So my next video is going to be talking about the standards and main concepts that you could address in this activity as you supplement, and some ideas to do that. One thing to do, though, you might have some groups finishing early than others. So I'm just going to mention now that you might want to direct those students that are done early, or you might want to, if you don't have computers in your class, you might want to print out, copy and print some of these read-ins you could get from the physics classroom, okay, the physicsclassroom.com on thermal physics or heat, because this provides a lot of the content that the students need to get from these lessons, okay? And these lessons don't go into great detail about the content of heat transfer, the methods of heat transfer, thermal equilibrium. So if groups are finishing early, print out, have some of these ready for them to read. You might want to create a few questions based on the reading for them to answer, okay? And that's what you could do with some groups that are finished early. And those that in the other groups, you could just give this out as a homework assignment. But there's a lot of good material here on the physics classroom on heat, okay, that you can give to students and groups that are finishing a bit early with their building and data collecting. All right, so again, you're going to have to supplement quite a bit here to make sure